that did not say $10. Yeah, those were Eric's words. Eric's wishes. So I did mention the number 11 too, but all of those were my numbers, not Matt's. And so to be fair to him. So our next speaker coming up is Steve Culman. Is Steve around? Steve, you want to make your way forward? So former colleague, current colleague within academia, I suppose, is Dr. Steve Culman. Steve's currently the Endowed Chair of Soil Health at Washington State University. Made his way all the way back to Ohio. We consider Steve one of us. How many of you know Steve from his former life at Ohio State? Okay. So thanks for Steve for being here tonight. He was with us for about 10 years, from 2013 to 2022. Steve's major project at that point, I regard as one of your major projects, was Tri-State Utility Guide revisions for Michigan, Indiana, and Ohio State. Evaluating soil health outcomes, conducting on-farm research, studying parental drain systems like Kernza. Steve, I think those of you who are in the old grain growers group entertained Steve a couple of occasions. You know that Steve's an advocate for Ohio organic grains. He's been that for a long time, and he understands Ohio's place, important place in the organic grain market and the grain industry. So, Steve, a few years ago, did this massive soil health assessment, and he teased out some of the data today with regard to organic.
Okay.
So, welcome, Dr. Steve Culman.
Yeah, because it was just a photo that we had saved. It was a picture of the weed buying.
Welcome, Steve Culman.
You know, like a little bit like a telemarketer let this thing on. I can do it today, Mr. Culman. Can I sell you some insurance? Is it okay? How's the sound? Good, okay. Thank you, Eric, for the introduction. Thanks everybody for allowing me the time to come back and share with you a little bit about some of the work that we've done. You know, I spent the last year and a half at Washington State, and I think I've probably worked on Ohio, tidying up and wrapping up Ohio State projects for a better part of that time. So today I'm going to talk to you about a couple things, and yeah, there's like a lot to share, and I don't have that much time. I've got an hour, which is probably more time than you want me to have, but I'll try to maybe cut it off at 45 minutes, and then maybe there's time for questions. Okay. Today, I'm going to talk about three things. I'm going to talk a little bit about, well, I guess I'll start a teeny bit with a little bit about organic matter, just because it's just impossible to talk about soil health without that. But I'm going to talk about a survey that we conducted in organic cornfields, and that will be kind of a big chunk of the talk. I will talk about this kind of more generalized soil health baseline, and then I'm going to get into. I just couldn't help myself with a crowd like this. You get people talking about soil balancing and calcium magnesium ratios, because we spent a lot of time thinking about this, and I know it's highly relevant in the organic community. So I just wanted to kind of spend a little bit of time on some of the soil balancing piece. Okay. And I've used this slide before, and I just kind of love it to kind of get us all like on the same page in terms of what we can think about organic matter. And we of course recognize the fundamental importance, the foundational piece for managing soils and organic matter management. And so it's just great because, for a long time, 1910 here, we've known about, it's not just the bank account, right? It's not the number in the bank, it's what's happening in there, right? It's the cycling and the dynamic nature. So I'll read these quotes to you. It is the decay of organic matter, not the mere presence of it, that gives life to the soil. So that's a quote from 1910. And then William Albrecht in 1938 said, attempting to hoard as much organic matter as possible in the soil, like a miser hoarding gold, is not the correct answer. It's not the right approach. Organic matter functions mainly as it's decayed and destroyed. Its value lies in its dynamic nature. That's pretty awesome stuff, and that was written a long time ago, right? People understood this, and in many ways, like this whole, this whole catch of soil health, there's essentially nothing new to it. It's all old principles, but there's a lot of like repackaging and making old things new again and shiny. And so I think that we've spent a lot of time thinking about organic matter in my time at Ohio State, and I still do this. But this is, we can imagine what's in the soil, right? We understand that it's organic matter is a small part of the soil, maybe 5, 3, 2%. And we measure this commonly with soil tests, but we can break this down, and soil scientists do this routinely to like think about conceptual pools. It's not all organic matter is created the same way. And so there's these passive pools, slow pools, and then in particular this active pool, which is where I focused a lot of time and my energy thinking about and trying to understand a little bit better. And say we have a 5% organic matter soil, well, the active fraction, so-called, might be 5 or 10% of that. So it's a pretty stinking small amount. This is where a lot of the biological activity happens, where a lot of the soils, it's rapidly cycle. It's important for crop nutrient availability and uptake. There's a lot of things that this active fraction has. And so I'll spare you the nitty-gritty detail. We can, I know there's been talk about this before, but we spent a lot of time, there's been talk in earlier talks about these measurements, but we spent a lot of time measuring a few things, really 3 principal metrics that we feel like are really important conceptually. So soil respiration, which of course is a measurement of microbial activity. This is a lab-based 24-hour measurement. We've got this POX, this permanganate oxidizable carbon. Sometimes it's called active carbon. And this really is a reflective of a more processed soil pool, but it's really biologically mediated soil pool. That's a very important pool. This is kind of a son of a gun because it's a hard thing to put your thumb on, but it's a very good rapid sensitive indicator. And time again across lots of studies across the country, this is a measurement that really just kind of comes to the surface in terms of it being useful and informative and quick. And then we've got soil protein, which is an organically bound nitrogen source. Okay, so unlike nitrate or ammonium, which is inorganic, this is actually a protein source, and this is the rate limiting step in that nitrogen cycling in your soil. Okay, so we've got carbon, we've got nitrogen, and then we got the crows or the bugs or the critters that are cycling all that. And we think that these 3 pieces together represent an important part of that active fraction of organic matter. Any questions, ladies and gentlemen? How are we doing this morning? Fine morning to be alive, right? Happy 2024, everybody. All right, so let's talk about soil health on organic farms. And of course, I'll start with kind of like an easy one, if you will. But organic production, we're presumably most of us in the room are proponents of organic production. We think that through many different practices, we can improve the health of the soil, right? This is what brings some of us to practice this way. But the elephant in the room, of course, is that we can think about diminishing results with the greater disturbance, primarily for weed control. Okay, so there's of course a lot of interest in thinking about how organic production impacts soil, and how does that relate to conventional production, if you will. And this question that we get all the time, which is how do management practices influence soil health? What can we do to actually foster soil health and improve the life and the well-being of the soil? And this won't, I won't talk much about this, but it's a kind of a complicated question. How do we get at this? How do we actually, at the university, how do we kind of start to crack this nut to give growers some tangible, helpful information that you can actually use and apply in your system? And there's really a few main approaches. We can start trials at university farms, and of course, academics like myself are good at doing that. We do that a lot. We can run on-farm trials, but on-farm trials, especially multi-year on-farm trials, are complicated. They require commitment. Lots of things happen on those, some for good and some for worse. And then we can think about this other piece, which is a much lower commitment, a lower bar, which is just like this idea of a survey, right? And this is, I'll talk a lot about this today. This is primarily what the talk will be, as a starting point for where we're at. The survey is not to think of that as like a telemarketer calling you, but just thinking of like a non-manipulated trial where we're going to go out and sample soil across a bunch of different fields and just survey where things stand. Whatever the history of that field is, that's what we're looking at. Okay, so again, this is a big approach that we've taken over the years. Okay, and so I'll start with this USDA funded or organic trial. It was really a soil balancing project. And we thought it was really important to kind of get a pulse, and I won't get into all the details, but I see there's colleagues in the room, and many of you here helped collaborate on this in various capacity. But basically, it was a 4-state survey in Ohio, Michigan, Indiana, and Pennsylvania. We looked for certified organic corn growers. There was a larger survey looking at practices, and then in that survey we asked if you were interested in a free soil health test, drop this postcard in the mail when you return the survey. So when they did that, we sent growers some postage, some instructions, and then asked for this survey to fill out, so we could get a little bit of history about what's been happening on that field, primarily over the last 4 years. Okay, so these are all certified organic corn fields, essentially. We got the soil back at the lab, and we ran a routine nutrient analysis, what I'll call routine, which is pH, organic matter via loss on ignition. That's the most common way it's done in commercial labs, and then malic-3 extractable nutrients. We ran this active organic matter suite of 3 tests that I just talked about: oxygen, respiration, and protein. And then soil organic carbon and texture were basically predicted with an infrared technology that we've developed. And we haven't developed the technology, we've developed the prediction equation, so we can rapidly scan and capture texture like sand, silt, and clay, and then total carbon with that. Okay. So this was the process, and we sampled the soils in 2018. I should say growers. Here's where we are. The shaded counties were where they came from, was 73 counties over these 4 states. And this is like a lot of work in itself, but we ended up with 195 samples, right? So it's like to think, if we might be naive for a second, or to think that these 95 soils or 95 fields really represented the vast kind of diversity that happens in organic agriculture across these 4 states. It's kind of foolish to think of that, right? But it's a start, right? And that's really where we're at. Most soil health talks you go to, one of the things on the conclusion slide is like, oh, we got a lot of work to do. We're just scratching the surface, and it's really true. There's just a lot of work that still needs to happen. Okay. So in that site history management survey, we asked growers to describe their history. We asked things about manure use. Nearly everybody was using manure, so that wasn't particularly helpful or important. Although we know it's important functionally, it wasn't helpful for us to understand the system any better. We asked about perennials in the rotation. We asked about crop diversity, quantified the number of crops over the last 4 years. Tillage frequency, we created this kind of tillage frequency index based on like detailed information about primary tillage practices, secondary, the depth, et cetera, et cetera. Cover crop usage, and then everybody's favorite, soil balancing. And I'm going to table this. I'll talk about that at the end. So I'm not going to get into this with this survey right now. Anyway, so stay tuned for that. And I'll just say, like, this was not particularly surprising, but there was a lot of variability that we found over 4 states, right? Different farms all growing organic corn. You know, we can recognize the complexity of organic cropping systems, and we certainly found a lot of that in the results that we had. We quantified how much soil texture plus all those management practices I just talked about explained how good were those things explaining variation across the sites, and it was about maybe 10 to 25% of the variation across the sites could be explained by soil texture and management. So just a lot of unexplained variability of that. Maybe of this, maybe 10 to 25%. The majority of that variation was explainable by texture. So soil texture really matters. Nobody needs a lesson in that. If you're farming, you kind of understand that. But when you move across the state and you're thinking about statewide assessments, you can't really talk about soil health and soil health values unless you're really binning those soils into, or like taking into consideration what the texture might be in that soil, right? So sand soils, of course, function differently, need to be managed differently than silt loam or clay soil, and that's really, I mean, maybe an expected outcome, but we really, it's something that we try to underscore when we talk about it. Let me show you a little bit of data. Okay. Remember when I told you there was a lot of variability and it was, you know, all over the place, and this is really what we found. So there's a lot here. Let me walk you through it. There's no way can you guys see this? Is there a way we can dim the lights at all or not? I don't know if that's a thing we can do. Can you see it okay in the back? It's probably small. Let me walk you through it. Thank you. Maybe that helps a little bit. We've got everything here is this crop diversity, right? So everything on this horizontal axis is crop diversity. Then we've got this POX, mineralizable carbon, which is another academic word for respiration. We've got soil protein, organic matter, soil carbon, and soil nitrogen. Okay, so what do we see here? We see as crop diversity, in other words, the number of crops in a 4-year period increases, we get declines in the soil health indicators, okay? And that's was a bit counterintuitive. We're like, what's going on here? I thought diversity was a good thing. I thought it was supposed to be helping with the soil. And what we realized that it's complicated, and it's really a function of tillage, right? So the more crops that are that are being grown in any given field over a 4-year period, the tillage frequency actually increases. So as our crop diversity, that number of crops increases, our tillage frequency increases. And conversely, this right here, gosh, there's just no way, and people in the back can read this. It says length of time a perennial is present in rotation over the last 4 years. So as the number of years in a perennial, the tillage frequency decreases as we'd expect because it's not a disturbed system. So what we found that there's for organic systems, there's this interplay between crop diversity and tillage intensity, right? The more crops that are grown, that's very intuitive to think about, but it had kind of measurable impacts in the data that we saw. So tillage, this is the same graph, except for instead of crop diversity, it's tillage frequency on this axis. So again, the greater the amount of tillage passes, the number got bigger, and this would be considered like a low or minimal till systems on this side. Our soil health indicators, we can see that there's kind of mixed results here. Really with respiration, we see with greater tillage increase, there's a general trend in decreasing soil respiration. That's that carbon dioxide evolving from the soil. But everything else, there's a lot of noise and just a lot of kind of unexplained variation. And I just think like this is a question mark for us, that we know that tillage is complicated. We know that it does good things and it does bad things, right, depending on your goals. And there's like interactive effects here that we haven't entirely teased apart. And I'll show you another slide about this in a little bit. In general, perennials in rotation increased respiration. So this was a kind of a really strong signal as we had years in crop rotations. our respiration value, our mineralizable carbon increased over time. Okay, so to kind of summarize this, I'd say overall, we were very optimistic about like digging into the data. And I think that we had a couple things. We had, even though we had 200 fields, it wasn't really a whole bunch of data. We really loved to have like made that number 5 times bigger if we could in an ideal world. And I think that there's certainly possibilities to continue to collect data like these and add to it. But, soil texture exerted greater influence than management, right? So in kind of the grand scheme of things, I think this is really just an important thing to keep in mind, that we need to know the type of soil that we're growing and talking about before we really talk about like comparing soil tests between growers or whatever. We need to make sure that we're comparing apples to apples and not apples to oranges. There's this interesting thing about like crop diversity, this relationship between tillage. So as our number of crops increase, our tillage increased, and it typically saw patterns and declines in soil health. Whereas when we had greater perennials in the rotation, our tillage decreased, and we had that was reflective of greater soil health. Okay. Tillage intensity again had kind of some mixed effects on some of our soil health indicators, and then the strongest signal that we found across this entire study, that perennials in rotation exerted kind of the greatest signal, right? So when we have low disturbance and lots of carbon input, particularly year-round carbon input in a perennial forage system, it's a good thing for soil. Does that surprise anybody? Anyone gonna argue that point? Like, I mean, that's like stuff again that we've known for quite some time. And then this idea that organic system management interacts with soil type, and it's a complex system. So there's a lot of things we scratch the surface here, right? And I think that we have learned some things, but there's just plenty more that is possible to get at. Okay, so organic grain conference, I highlighted an organic corn grower survey. This is kind of complementary work. We've done a number of this. I'm going to talk about this baseline assessment, which is again kind of similar principles, but these are projects that primarily I ran in my lab, but maybe others as well, from 2015 to 2021. This is one of the kind of the last things that I did before I departed Ohio State. We ran these projects. There was really 10 individual projects that were both conventional or organic. There was a bunch of different crops that we looked at. So these projects all had different purposes and whatever, but for the sake of kind of doing this baseline assessment, we compiled all these data together. Most of the soils in here were conventional, from conventional fields, mostly grain fields, okay? And it's the same kind of principle where we like mailed a management survey and instructions, and samples were pulled and mailed back, and then we ran these analysis. We gave the results back to the growers. And here's where we were at the end of all this. We had better part of Ohio ag represented. The red counties are those that were sampled. About 2,500 soils. And really, there's a lot of different things that this is still work that's in progress, but we wanted to do a couple of things. And the first one is like, again, it's really rudimentary. It's baseline, which is like just creating an understanding of like what's a relatively good or a bad number when we talk about soil health, right? So a lot of like the frameworks have been developed, for example, like, at Cornell, and that's upstate New York, and mid-Atlantic, different soils, different systems, and we wanted to get like an Ohio context for this, right? And the second one, which is like we're still working on, and this is like not something it's not a nut that we're gonna crack with this study, but like it's just this idea of like, can we, as an example, what has greater influence on respiration values, like no-till or cover crop? Or like, what's the functionality of like respiration as an indicator? How can we use that information to help inform management, right? So anyways, I'm going to talk a little bit about this, but it's not much to share. I'll say what we did We took these values, we broke it down into the 3 different soil types, coarse, medium, fine, based on soil texture. We also did this based on CEC, so if you don't know the texture, your textural class of your soil, you can just use CEC as a proxy for that. And, you know, there's a table here, and it's basically broken down in the quartiles. So we can see, like, for organic matter, for a medium soil, this would be considered like a silt loam soil. What a typical organic matter value that you would see in a soil test from a commercial lab, what would be low, what would be medium, high, and very high. And likewise, we have total carbon, this permanganate oxidizable carbon respiration soil approach. Okay, so this is just like the first step. It's like what we consider, you know, ages ago, NRCS went out and mapped soil, right? They like went around, and they're actually still doing it, but Ohio's been completed for a lot of years. I don't know, when was Ohio's soil survey completed? I think that's a trivia quiz. It's sometime in probably the late 70s, early 80s, something like that, maybe in the 90s. Some follow-up stuff, but that work is primarily done. And so they went out and they mapped soils and said, this is where we're at. And this is a much smaller and analogy to that was this idea of soil health. So you can find this report and at go.osu.edu, capital SH-baseline. So it's go.osu.edu soil health baseline, SH baseline. And just feel free to, you know, find me or Cassie or Eric. We can, if you're interested in looking at this. But this is, again, just the first step, just to kind of see what a good value is and what that looks like. It's a common question that we get when we return results to the growers. You know, what's my value? Is that good or is that a bad thing? What's, you know, is a 450 pox value a good thing or is it bad? So this work is done for now. Like this is kind of a tangible thing that's out. And I will say that it's not really done because we're still I can't really use the we pronoun there, but there's still work being done. Good folks at OSU Extension are still doing some of this work and running it through eFields. So Elizabeth Hawkins et al. Are running some of these trials, and you know, with funding, I connected with her a couple of days ago. She said they're trying to do this in 2024, depending waiting word from funding. So opportunities to essentially get your soils, you know, analyzed for kind of a free soil health test. And I should have said this much earlier, but what we've done, like there's a lot of things you can run on a soil health test. We haven't run like the whole, you know, suite, right? Like there's no, if you look at like what some labs provide, particularly the Cornell, the cash assessment, they run a number of other tests that we haven't touched here. So that's another whole other bag of worms, is like what actually should be measured. But so anyways, this is eFields data. So again, this is from these counties from 20 and 21. This is just showing that like for individual projects, we've looked at how management impacts some of these soil health values. So, but in the totality, there's still a lot of work to do pulling all this information together. So here we have years in no-till on this vertical axis. So each one of these axes is years in no-till. And then on the bottom, the 3 bottom panels, we have years in cover crop or in perennial. Okay. So as the values go from left to right, we think that values should increase in general, right? Our measurements are total organic matter from a commercial lab test, this permanganate oxidizable carbon and respiration. Okay. And like I was saying before, there seems like a pretty clear relationship with years in cover crops. There was a few fields in perennial, but most of these are really years in that cover cropping had been done. Like how long have you been cover cropping that field? It's really what most of what these bottom graphs represent. And we see kind of strong relationships with that. Even if we take these 25 years out, there's still that relationship holds. But with tillage, it's just a more complex and nuanced story. Because you're, you know, when you're tilling, you're putting carbon into the soil, and the type of tillage and when the tillage occurs, it's just a lot more complicated. So I'm not like this ardent no-tiller. I know that those folks do exist, but I'm definitely not one of them. I think that there's a lot of value for tillage, but in general, of course, we're trying to minimize that to the extent that we can, right? And these data just show that it's not, it's not binary. It's not if you till, it's great. I mean, if you till, it's bad, and if you don't till, it's great. So there's a lot of there's just a lot of information that still needs to get teased out of this. Okay. Now I'm going to shift gears and just talk a little bit about soil balancing, and this will wrap up the talk. Okay. So sometimes I ask for a show of hands for who balances soil, who does this, but I won't do it today. It's soil balancing and the concepts of soil balancing have been around for a long time, for over 100 years. The nerdy soil dorks like myself might call this base cation saturation ratio, right? This is often what it's referred to in kind of the literature. We can just call it soil balancing for this, but we'll use these terms synonymously here. So this kind of management approach, of course, is thinking about the roles and the relative ratios of calcium and magnesium and potassium and how those play on the exchange site and the functions that flow from that, right? That's the whole idea. This idea that Albrecht really came up with, I mean, it preceded Albrecht, but with his papers, there was a lot of popularization of this, thinking about calcium-based saturation percentages, somewhere between 60 to 75%. Even most people that really practice would say 60 is a little on the low side. 10 to 20 for magnesium and 2 to 5 for potassium, right? So when we get the soil, as the thought goes, we get these soils in this kind of balanced range, and then good things flow from that, right? Part of this organic soil balancing project that I mentioned, Doug Jackson Smith et al. Led a organic corn survey that I mentioned previously, found that 55% of the organic grain growers in that 4-state region really kind of subscribe or actively manage soil for these ratios, right? So it's widespread, it's prevalent. There's certainly non-organic entities in Ohio and elsewhere that really think about this and actively manage for it. And it's something you probably don't need me to tell you this, but it's something that like scientists, soil scientists for decades have said this is all like, kapooey. It's not a real thing. And so we wrote this grant because it's just, it's like there's there's the scientists and then the growers, and nobody's talking to each other and trying to figure any of this out. And so, we really didn't appreciate this before we wrote the proposal, but after talking to a lot of people, just thinking that like people think about this and practice this in lots of different ways. So it's a little bit even hard to like define what the heck soil balancing is, but we came back to this idea that it's really about base saturation percentages or the ratios, okay? And so this is a big chart, but this is kind of like it in a nutshell in terms of what we found. So in practice, this soil balancing or BCSR, the fundamental question is the soil acidic, right? And if it is acidic, we add lime. And what is lime? It's calcium, it's carbonate. And if it's in optimal pH ranges, then we're going to add something gypsum. And maybe they'll add both, right? Maybe we add lime and gypsum even if there's a low pH. But gypsum is calcium sulfate, right? So we've got calcium carbonate and calcium sulfate. And then these are the mechanisms. Again, you probably can't read these, but let me just mention a few of them. For liming, the carbonate increases pH. And what does that do? There's a bunch of mechanisms that happen, right? So these boxes are really like the mechanisms that we know are meaningful, and then these other boxes on the bottom are like a little bit more, we don't totally understand what's going on with that. But when we add carbonate, we increase the pH. Of course, we neutralize acidity. That's we influence the speciation and availability of nutrients. Microbial activity increases root exploration, right? And we understand that pH, in some ways, in like the nitty-gritty details of soil science, that pH is important for stabilizing carbon, for building carbon, and it acts in ways that we don't, like on the molecular level, that we don't entirely understand fully. But, and then there's, with this gypsum, there's calcium sulfate, and sulfate is increasing plant available sulfur, and it does things over here as well. I won't focus on that. But when we have both, of course, adding lime increases calcium saturation, right? Like, and adding gypsum increases calcium saturation. So you're both putting calcium in fairly large amounts in the soil, and that's bumping up the calcium is bumping ions off the exchange sites, and you're increasing the amount of calcium on those exchange sites. Okay, so what does that do? It increases, of course, the saturation, reduces sodium levels in sodic soils. That's not an Ohio problem. It's a big problem in the West, but it's not an Ohio problem. Reduces magnesium and calcium availability, and that can sometimes lead to deficiency if there's too much of a good thing, right? We know that it reduces complexes with phosphorus and can reduce offsite phosphorus transport and phosphorus availability. But then kind of the big ones are reducing magnesium levels leading to improved soil aggregation. How many people have heard this? If you have too much mag in your soil, you're gonna get it's gonna be a tight soil. That's why you need to add calcium to loosen that up, right? That's like this is like I don't know what to call it, doctrine of a lot of soils, right? And so we could talk about all the studies. This has been demonstrated in the laboratory with soils, but it's like when you jack the mag saturation up to like 80%, right? So it's like not what you would natively find in soils, certainly not in the Midwest. And there's like some debate about this, right? Like how much that mechanism actually matters and what does it do? It's hard to really like put a final box around that, okay? And then we know that increasing calcium plays important roles for building total organic matter, carbon stabilizing again. So these are all important, okay? Anyways, the question here, ladies and gentlemen, is when we add lime, we increase calcium saturation. When we add gypsum, we increase calcium saturation. How do we know which one is helping? How do we know? Brings me to my favorite scientific, everyone's favorite scientific philosophy, which is this idea of correlation versus causation. Because things are correlated, does it mean we can assign causality, right? So here we have a graph. The green bars represent Internet Explorer market share, and the blue dots indicate the murder rate in the United States. Okay, so the logical thing to conclude here is as people stopped using Internet Explorer, murders drop precipitously, right? Here we've got total U.S. highway fatality rate versus the number of fresh lemons imported into the United States from Mexico. That's why there will be lemonade at lunch today, because we're trying to encourage a lot of consumption of lemons. And then my personal favorite, which is the number of people who drown by falling into a pool versus the number of films that the great Nicolas Cage has appeared in. So if only Nicolas Cage would stop making movies, we could eliminate the number of drownings in pools. Of course, this is like just stupid, silly things, right? But it's the same idea. We go back to this idea of which one of these actors is doing it. Is it pH? Is it calcium saturation? And this is like these things that are intertwined that we can't easily tease apart, okay? So going back, I'm finishing up here, but going back to that organic corn farmer survey in the beginning that I was talking about, we see calcium magnesium ratio on this axis, and we see this POX, respiration, soil protein, organic matter, carbon, nitrogen, generally positive lines, all but this respiration. We basically see some positive, very slight positive improvements as the soil calcium magnesium ratio increases, right? So this was interesting, and we thought that this was a signal, and it certainly might be. We just don't really understand what that is. We do know that when we ask these same principles or the same growers, do you subscribe to it? Do you actively manage those soils for soil balancing to manage? We could not find a difference. And again, this is just 200 samples, but we couldn't find a difference. We would think that if you're managing for BCSR, that calcium saturation would be higher. We would expect that that red line would be higher, the shifted over to the right versus this blue dotted line, and the magnesium saturation shifted to the other way. But it's just not what we found. We couldn't, tease these apart. And we also found that when, I'll just say it and then I'll explain the data, but managing soil acidity in Ohio soils basically balances soils regarding calcium saturation, but not magnesium. Okay, so this is a database from Spectrum Analytics, 335,000 soil samples, mineral soils across Ohio over 5 years. And we can see this is calcium saturation. We've got pH in low, optimal, and high. And these lines represent where Albrecht says we should be, right? That's 60 to 75% calcium saturation. When soils are out of range, when they're less than 6, this red dotted line, the calcium saturation is low. Of course, when we lime soils, it shifts our calcium up, right? And that's what we see here with this optimal and high kind of in range. Magnesium is not the same story. So one of the take homes here is like when folks are balancing soils, they're using lime, they're using gypsum to do that. What's the acting mechanism? What matters? Is it neutralizing acidity? Is it increasing calcium saturation? Those are hard things to really tease apart, okay? The long-term study that we did at Herzl, the Herzl farm, this is in Wood County, about, 22 years in organic production, and a West Badger farm at Ohio State Farm in Wayne County in Worcester. This is a silt loam soil. This is a Worcester silt loam. This is a Wheatville clay. And we can see our soil calcium magnesium ratios over 6 years and the relationship with grain yield. Now this is in megagrams per hectare, but the units don't really matter, right? You can see that we found no signal in what was happening as we took soils and we put them in opposite directions. We increased the calcium to the magnesium ratio and we decreased it. And we really found no effect on yield over time. This is again, and from that Worcester site, showing this is grain yield, this is in bushel per acre, so that gives you, it's really the same data is right here. It's just split up into 2 different crops, corn and beans. We've got calcium magnesium ratio here, no relationship at the Worcester silt loam soil, and soil pH. No relationship there. So like which one's the bigger hammer, right? Is it pH or is it calcium magnesium ratios? And so we looked hard and as diligently as we could to find signal. And I'll just show some work. This is certainly not all inorganic systems, but just to give you a flavor of some of the work that's happened over the last 8 years, 10 years on this. And a lot of this is out and published right now. We had the study that I just mentioned, corn and soybean small grain. This is organic. 2 sites in 6 years. Calcium magnesium had no effect on soil health, crop yields, only soil pH. We had organic on-farm trials that master's student Lisa Florida ran for 2 years on 14 organic farms. We found no effective gypsum on crop yield or soil health. Sorry that this is like the Debbie Downer part of the talk. Gypsum rate, this is a conventional system, 4 years in 2 sites. Gypsum increased yields in 1 out of the 8 site years. It was a first year, and we think that was a sulfur effect, not a calcium. All this is gypsum applied at like 1 to 2 ton rates. So this is like what would be done commercially. On-farm gypsum trials. This was a one and done, 1 year, 62 trials over 27 counties. gypsum increased yields in 2 of the 26 site years, or 2 of the 26 trials where gypsum actually increased yields. And, we say increase, that's like a statistically significant increase. That's a high bar to set, but these are all randomized, replicated trials. But we did not find much signal here. Gypsum and lime trial in muck soils in Willard, Ohio. This is a vegetable farm, 5 years of vegetables over 4 years, or 5 vegetable types over 4 years. Gypsum, no effect on crop yields, only pH. Should I keep going? It's the same thing over and over. So we've looked really hard, and I'm not saying we know, like, this is not the definitive answer, but boy, we've tried our damnedest to understand what the net positive effects of gypsum on soil. And so I'd say, despite widespread use of balancing in Ohio, demonstrating the positive effects on crop productivity has been very, very elusive. So soil pH and managing acidity is the big hammer. And that any benefits of soil balancing might really only be realized in combination with other practices, right? Science is really good at finding one effect and holding that effect constant and manipulating that. But when you add all these other pieces into play and you get a bunch of interactions, it's not particularly good at that. So I'm going to wrap up by saying some concluding marks. So soils are wonderfully complex. We can appreciate that. Management clearly impacts how they function and how they that the health of that, the vitality of soils, and they take a long time to change. These are like all things that are across Ohio, the number of soil types, how they're managed, and how long the dynamic state of all those soils is that's just a lot of complexity. So understanding how management impacts health and functioning is really challenging. Like there's a lot of things in this world that are really challenging, right? Like all the easy stuff has been done. Sorry, Gen Zers, but like you only have hard problems now, right? So and I just say, because of the complexity and because of these 3 pieces, that farmer collaboration and your shared experiences are a critical part. Like we can only do so much at the university in terms of like running field trials and understanding stuff, but we need these types of collaborations and your story to understand, like to help us move and understand exactly what's going on. So we live in an uncertain world, and when it comes to soils, there's a lot of uncertainty managing soils, but we're trying. It's a long road to hoe, so I'll end there and happy to take any questions. And I didn't mention my collaborators, but there's like a lot of people in this room that like fed into this, so thanks for that. You're kind. I don't know if we have much time. Probably not. Yeah, go ahead.
Yeah, from what I saw on your graphs, so for soil health, no-till didn't seem to make any difference, and crop diversity didn't make any difference. Only perennials made a difference. And
I'm also signing
you
up
were
for
saying that the tillage might have had a detrimental effect
So I'll
on
be
by the
back.
perennials because they weren't productive. Is that just an assumption, or is there any evidence to back that up? Because the graph doesn't look like it back that up.
Right. So in terms of
Well, on a second note, this, because the perennials are not very diverse, did the life of the soil evolve to adapt to that one crop, and over years increase soil health because they adapted to that one crop for all the years?
Yeah, it's a great question. So the question about the first question, which was like perennials being the biggest signal in terms of the management. So I think the takeaway from some of you saw the line with tillage frequency, and it's a flat line. There's a lot of data points above and below it. The take home isn't that tillage doesn't matter, doesn't have an effect. I think the takeaway is that there's just a lot of complexity, and depending on the system, it might be. I didn't show you a graph, but we actually split that tillage out in terms of when there was perennials in the system and low tillage and when there wasn't, and then those lines actually changed, like the trajectory changed based on those two groups of data. So it's, you know, these broad strokes, right? These broad brushes of like tillage does this in an organic system or tillage doesn't do this in an organic system. I'm not sure we can do that, right? Like I'm not sure that it's that cut and dry, and that's one of the lessons. But getting to the perennial question and thinking about like what you know, the adaptation of that soil over the last 2, 3, 4 years when the perennials in it, does that play into it? And I'd say probably like there's some stability and things that are happening in that soil. A lot of our measurements are not like, you know, they are sensitive measurements, but oftentimes they'll take 2 or 3 years to actually you see a change in. So, you know, even though like the biology might be changing instantaneously when you plant a crop or expose to a new species, the measurements that I'm showing here aren't that hypersensitive, right? So it's yeah, there's just, I don't really know how to answer that, except it's complicated, and you know, there's a lot of things that we could measure that we really didn't for the sake of time and money.
When you change calcium or acidity, do you take measure to see the impact of microbiome for the microbiome diversity and the microbiome biomass?
Yeah, it's a great question. So when we manipulate the calcium magnesium ratios and the pH, that we look at like soil, microbial biomass, and food webs, and we ran a PLFA analysis to look at microbial communities. We found no significant differences with the gypsum, and because we had some plots where we applied gypsum only and some plots where we applied Epsom salt, magnesium sulfate, and we saw no differences there. We did see differences with the pH when we had lime in it, and microbial biomass, probably the same result, although I can't recall off my head. Yeah, so yeah.
On all this list of all these farms where it seemed like no effects were happening, what were the base saturations of calcium and sulfur? Like, were they already adequate?
Great question. Yeah. So the question is about what were the pre-existing base saturations. So we haven't been particularly picky or selective about that. We did put another round of funding in to say that we were going to be picky and only go after high mag sites and try to, you know, but we were not able to get money to do that. So the answer to your question, all over the board. Some people had been already using gypsum. Many people had not. It really just depended. Yeah, but it's an important, yeah, a great idea in terms of where was the starting place, obviously, because you start from a soil that's got high mag saturation, you might see a different story, right? But we certainly we asked for soils like that, and we found some of them. They weren't like populated throughout in all of the studies. So yeah.
So what time of year did you guys do the like soils testing for the health? And do you feel like that might have changed if it was a different time of year?
Yeah. So a survey like this, we asked for samples in fall sample soil. It's typically what we would do. That would be formal practice. Some of the other of the 10 studies, some of those were spring sample soils. All of like our fertilizer recommendation soils, which actually went in some of that data too, were spring samples before fertilizer was applied. Just soil sampling time.